Hi, in this video, we'll be covering error handling in Java. Let's first take a look at runtime errors. These kinds of errors occur during program execution and can lead to unexpected program termination or behavior. They can be caused by different factors, but some of the most common ones are invalid input. For example, let's say you have a program that asks the user to enter their age and you expect them to enter a positive integer. However, if the user enters a non-numeric value, such as ABC, and your program tries to perform mathematical operations on that input, it would cause a runtime error due to the invalid input. Resource unavailability is also a common cause of runtime errors. Suppose your program needs to read data from a file, but the file does not exist or is not accessible at the specified location. When your program attempts to open the file and read from it, it will encounter a runtime error due to the unavailability of the required resource. And lastly, logical mistakes in the code can also cause runtime errors. Let's take a look at some example programs. In this first example, we have a program that tries to divide a number by 0. In this first example, we have a program that is trying to divide a number by 0, but we know that that's not mathematically possible, and it will cause a runtime error. Let's walk through this program step by step. We initialize the numerator to be equal to 10. We then initialize the denominator to be equal to 0. And then we create a result variable that will hold the value that results when you divide the numerator by the denominator. When we try to run this program, we'll get an error message, and it will look something like this. This error message gives us important information about where the error is happening and what type of error it is. Let's take a closer look. It's telling us that we have an arithmetic exception, and specifically, it's caused by attempting to divide by 0. It then goes on to tell us that it is happening inside of the main method of the example file on line 5. And if we go over to our line 5, we see that that is where we're trying to do this division operation. Let's look at a different example. Here we have a program where we're trying to access an element in an array that is out of range. Let's go through this one step by step as well. We have an array with 3 elements, and the indices are 0, 1, and 2. Then on the next line, we see that the program is trying to access a 4th element by accessing the 3rd index. This will cause an error that will give us an error message. Let's take a closer look at this message as well. We see that it's telling us we have an array index out of bounds exception, and that the specific index is index 3. Again, it tells us in what file, what method, and on what line it's happening. So if we go to line 4, we see that that is where we're trying to access a 3rd index. Something that you might have noticed is that in both of the examples shown, the message says that there is an exception in the program. And then it also tells us the type of exception. So what exactly is an exception? Let's take a look. Exceptions are events which occur during the execution of a program that disrupt the normal flow of the program's instructions. When an error occurs inside of a program, the program creates an exception object which contains information about the error. The program then hands the object to the runtime system. The Java runtime system consists of code that is necessary to run all Java programs. This whole process is known as throwing an exception. When there are no exception handlers put in place, then the program will end abruptly and display an error message. So what does it mean to handle an exception? Exception handling is important because it helps maintain the normal desired flow of the program even when unexpected events occur. There are different ways to handle exceptions, but one of the simplest ways is by using a try-catch block. When using a try-catch block, you want to put the code that you want to run inside of the try block. Only the code that can possibly cause an error should be included inside of the try block. Then, you use the catch block to catch any of the exceptions that might be thrown. And you can use multiple catch blocks for multiple exceptions. Let's see how this works in more detail by revisiting one of the examples from earlier. Here's the program that attempts to access an index that is out of bounds. Let's create a try-catch block so that the program doesn't abruptly terminate with an error message. We first want to put the code inside of a try block. Notice that not all of the code is inside of the try block. Choosing the appropriate code to place inside of a try block involves identifying the sections of code that have the potential to throw exceptions. The general guideline is to include only the minimal necessary code within the try block that is directly related to the potential exception. So in this case, we don't need to have the initialization of the numbers array inside of the try block. Next, we use the catch keyword to begin the catch block. The catch block requires you to pass in the exception that you want to handle as an argument. In this case, the program needs to handle the array index out of bounds exception. If you recall, that is the exception that was provided by the error message earlier. The E variable inside of the catch statement is commonly used to represent the exception object that is caught by a catch block. The object is essentially stored inside of the variable E. You can use the object stored in E to help give more information about the error, but it is not necessary. Now, if the program were to have code after the try catch block, it would still execute even if the exception was thrown. So, in order to catch an exception, some code somewhere needs to throw an exception. And that code can be the Java runtime system itself, which is what we've seen so far. It could also be code that someone else wrote, such as an imported package or a library that you're using. And it could also be code that you write yourself. You can throw standard exceptions or custom exceptions. This route should really only be chosen under certain circumstances, such as you need an exception that is not included in the Java platform. Regardless of what code is throwing the exception, exceptions are always thrown using a throw statement. Let's take a closer look at the syntax for how to do that. You first need to start by using the throw keyword. When your program encounters this keyword, it will interrupt the normal flow of the program and start looking for a place to catch the exception. Next, you use the new keyword. This keyword creates a new object of the exception that you want to throw. Next is the name of the exception. You can use standard exceptions like the ones we've seen already, or you can create custom ones, which we'll see later on in this lesson. Lastly, you have the constructor argument for the exception class. It's a string that becomes the message of the exception, which gives information about the error that occurred. And that's it. Let's now explore these concepts further in the following activities.